Welcome back. Next phase of this numerical is we have to find out the moment of inertia of this lamina about its centroidal axis. Okay. Then we have to mark the centroidal axis of this shape. Now the centroid of this shape is x bar at 2.995. It is almost 3. Okay. And y bar as 1.89. Okay. It is almost 9. So if I mark the location of centroid in this figure, it should come somewhere here, very close to this, because it is almost 3. 2.993 is almost 3. Okay, but it's okay. Now if I and that's how we can mark. So it is x bar and this is y bar, right? Okay. Now actually in this we have to apply the parallel axis theorem. Now that means first let us say if you have to find out the moment of inertia about this axis. Okay. So if I draw these three shapes, this one, this two and this three, on a different paper in this fashion, then we can in this is the its own centroidal axis, and as we can see you have to find out the centroid about this axis, and this is almost, and this is, if I, it is like this, and if I again for this, it is like this, and if I mark for this, it is like this, right? So if I mark the IXXG, I1 plus I2 plus I3, and I1 that is for this shape. Now for this shape, now we know for this, about this line, the moment of inertia is pi by 128 into d to the power 4. D means diameter, that is 4 to the power 4, and this is about this line, right? Then we have to apply the parallel axis theorem, because what you are interested in, you wish to find out the moment of inertia about this line, and you know the formula about this line, and you wish to find out the moment of inertia about this line. So the parallel axis theorem says area of the shape we can see from this formula as 2 pi. Okay, that is 2 pi multiplied by distance. Distance is how much? The distance between the two is this shape, right? And this shape is how much? From this to this distance. The earlier from this to this distance, and this is y1. Okay, y1. And what is y1? 2. And minus x bar minus y bar. And what is y bar? Y bar is 1.89. Okay. 1.89. Just to bring little more clarity, it is this and it is this, right? And we know that the formula is whole square. Parallel axis theorem says the moment of inertia of this shape about its own centroidal axis, which is this, plus area of the shape multiplied by distance between the centroid. So distance between the y1 minus y bar and whole square of it, right? Plus second term. Second is for this. Now we always know the moment of inertia of this shape about this axis is 4 whole cube into 6 upon 12, right? We know that we have to cube that side which is cut by the axis line, right? So that is why it is 4 cube, because 4 is the length which is cut by this axis, multiplied by area. Area is A2, which is 24, multiplied by again y2. Y2 is 2 only, and minus 1.89, which is y bar. Right? And plus third one. The moment of inertia about this line, which is equal to we have to make cube of this height, and this height is 4 whole cube multiplied by base is this, which is 3, okay, 3 upon 36, plus area A3 we already know it is 6, multiplied by third y3 is equal to 4 by 3 minus y bar, which is equal to 1.89, and that is equal. And so this is the moment of inertia of this lamina about its x-axis axis, right? Is it okay? Now if you have to find out the moment of inertia of this shape about its vertical axis, that is this vertical y axis, right? Then just for the ease of convenience, if I draw the y axis in this, it will be like this. On this it is we can see it is 1.29. it will almost lie on this line, right? Just, and in this it will be like this. So I think it will be better if we understand by this line only. And for in this I y g is equal to I1 plus I2 plus I3. I1 is for this, right? So it is, now for this you have to find out the moment of inertia about this axis, and about this axis it is 0.00646 d to the power 4. What is d? 4 to the power 4 plus parallel axis theorem. Parallel axis theorem is area 2 pi multiplied by distance between the two. Distance between the two is this distance, right? And this distance is x1 minus x bar, x1 minus x bar and whole square of this. Now if we can see that x1 is equal to minus of 8 upon 3 pi and y bar is, x bar is 2.99. So it is okay. This is minus sign. We have to see it is minus sign. It is also minus sign. So this will add. And this we can see in this diagram also, that the distance will add into it. So no issue. In this also it is already added. The for second shape, we know for this it is 6 ka whole cube into 4 upon 12 plus area A2 multiplied by x2 minus x bar ka whole square. And for third it is 3 whole cube into 4 upon 36 plus A3 multiplied by x3 minus x bar ka whole square. And value of x2 x bar, x1 x bar and x3 x bar you can take from this table and this table. I think it is okay, right? Thank you.